Hello viewers, welcome to my channel once again. Today in this video I will discuss about some important points behind the gold medal achieved by Niraj Chopra and who makes each and every Indian to feel proud after the Tokyo Olympic 2020. Before going to the next, let's have a look at the historic moment of Niraj Chopra during his Tokyo event. This is the throw of Niraj Chopra, after which he was able to uh, get the gold medal for India and make us very proud for him. Okay. This is the historic gold medal. Now let's uh, discuss about the history of javelin throw. The men's javelin throw was first introduced in the Olympic game in year 1906 with some uh, few rules and regulations. And in 1912, with the formation of International Amateur Athletic Federation (IAAF), some strict rules and regulation was imposed on the javelin throw event, and the world experienced the first world record measuring 63.32 meter by the legend Eric Lemino in the year 1912, 29th September. And after that, following many years, in 15th May 1983, an USA legend Tom Petranoff made the highest record measuring 99.72 meter of javelin throw, and again that record was broken by German athlete Uwe Hohn on the year 1984, 20 July, and his throw was measured as 104.8 meter, and this throw was supposed to be the majestic throw ever occurred, and this record is set as now it is set as eternal record, because up till date this record cannot be broken, and again it cannot be broken in the future days also, because after 1986 the javelin throw is again go through some other changes, and therefore Uwe Hohn records become the historic record with this tremendous throw of 104.8 meter. And again, another important point, the women's javelin throw was introduced in the Olympic Games in the year 1932. Okay, so next come to this point. These two celebrities, I think all of you can recognize these two celebrities. This is Niraj Chopra, India's gold boy, and again this one is the historic man Uwe Hohn, who made that eternal record in javelin throw. Okay, so this is Niraj Chopra during his event in Tokyo 2020, and this one Uwe Hohn during his javelin throw in the year 1984, when he made that majestic eternal record. Okay, these two celebrities makes all of us to feel proud during, because of their uh, uh, valuable effort in javelin throw. Okay, next come to that historic moment on the year 1984, during which Uwe Hohn made that eternal record for his javelin throw, measuring 104.8 meter. Okay, that was that historic moment, for which each and every man surprised by his throw to cover such a tremendous length. Okay, now let's discuss some scientific point behind the javelin throw, behind the javelin and behind the javelin throw. This is a model of javelin that was used by Uwe Hohn. This is the center of mass of the javelin, and this is the center of pressure. Okay, and this javelin was used by Uwe Hohn up to 1984. Now one point is, what is the center of gravity? The center of gravity is that point through which the earth gravity act on the uh, total mass of a body. This is the center of gravity. And again, what is center of pressure? Another point is center of pressure. So center of pressure is that point on which the aerodynamic forces act on a flying object. Okay, so what is dynamic forces? These aerodynamic forces are the uh, dragging force offered by the resistance offered by the wind velocity and any other atmospheric factors by which some opposing forces act on the flying body, and all these aerodynamic forces act upon a single point, and that means the resultant of all these aerodynamic forces act on a single point of the flying object, and that point is known as CP, or center of pressure. Okay, so this is the model of javelin that was used by Uwe Hohn to make his historic record. Okay, and during the during his Uwe Hohn's effort on javelin, the javelin thrown by Uwe Hohn supposed to follow this type of projectile path. This is the javelin. Okay, and the javelin move like this. Okay, these are the uh, different position of the javelin thrown by Uwe Hohn, where we can see the javelin. At first, the javelin was thrown upward by the athletic during his athletic event, and then afterwards the javelin slightly go down like this, and after some time the javelin appears to be flat according to the or relative to the ground, and finally the javelin land on the uh, ground like a flat stick. Okay, this is the flat landing of the javelin. Okay, so up to 1984, and including Uwe Hohn, the javelin flight is supposed to be like like this, where the javelin landed on the ground like a flat stick. Okay. Now, what after 1986? In 1984, Uwe Hohn made that eternal record of 104.8 meter by his javelin, and after that, in 1986, the javelin was redesigned to some extent. The javelin was redesigned by IAAF, which was effect from 1st April 1986. So what was that changes made upon the javelin? So this is the original javelin used by Uwe Hohn up to 1984. Okay, this is the C center of gravity where the weight of the javelin acts, and this is the center of pressure where aerodynamic forces act. Okay, this is the javelin used by Uwe Hohn. Now the new design of javelin is like this. This is this center of pressure, and this is the center of gravity. You can see here in the first one, the original one, center of pressure and center of gravity lies on the same point, but in this redesigned javelin, center of pressure and center of gravity are some at some different point. These 2 points are separated by each other, and how much separation between this point was done? It is about 4 centimeter. That means the center of gravity was shifted in the forward direction by 4 by 4 centimeter. So there is, because of this shifting of center of gravity, there is a difference between these 2 points, center of gravity and center of pressure. Okay, so center of gravity moved forward by 4 centimeter. This is the redesigned javelin used by Niraj Chopra. So Niraj Chopra, who got the gold medal for India in Tokyo 2020, used this type of redesigned javelin. Okay, the tip of the javelin also made blunter. The tip also made blunter, so that all these changes helps the javelin to fly a shorter distance and start to descend earlier with a steeper angle to stick into the ground, avoiding the flat landing. Okay, and the women's javelin was redesigned in 1999. Men's javelin was redesigned in 1986, but for women, the javelin was designed in 1999. So, what was the advantages of was the causes or advantages of these changes that done upon the javelin? So, first of all, when Uwe Hohn made the majestic throw beyond 100 meter, it was very supposed to be very danger that it may cross the stadium and the javelin can hit some people after crossing the stadium. Therefore, these distances, no one can say how much energy can be in some athlete, or he can throw the, to what extent he can throw the javelin. So if the javelin passes or thrown across the stadium, beyond that stadium, it may hit some people, or it will be very dangerous situation. Therefore, to uh, avoid that type of dangerous event to be happen, the authorities think about some precaution with which the uh, distance covered by the javelin made in between the stadium, so that it cannot cross the stadium or hit someone. So keep in mind this point, the javelin uh, is redesigned by uh, shifting the center of gravity in the forward direction from the center of pressure by 4 centimeter, and again the tip of the javelin also make blunter, and this always changes helps the javelin to fly a shorter distance, because as the center of gravity comes forward, then when during the fly of the javelin, the javelin start to descend earlier uh, compared to the original javelin, and again the javelin stick on the onto the ground, uh, because in through the original javelin, the javelin was landed like a flat stick. There was flat landing of the javelin, but with and that type of for that type of landing, the judges were confused to measure the distance of the throw, because the javelin was uh, landed flatly landed on the ground, and it slided to some distance. Therefore, the judges were very confused to measure the distances of the throw. Therefore, the javelin was redesigned, or the tip of the javelin was redesigned in such a way that the during the flight of the javelin, it started to descend earlier compared to the original one, and it will stick into the ground, uh, avoiding the flat landing, so that the measurement of the throw can be very uh, efficient, can be very accurate. So that's why the this original javelin was redesigned in 1986, and with this redesigned javelin, no one can cross beyond 100 meter. Okay, that means the javelin throw distance of the javelin throwing is reduced by about 10% compared to the earlier javelin. Okay, so with this type of changes, the risk of going beyond the stadium is reduced. Therefore, nowadays no one can cover by javelin throw up to or beyond 100 meter. Therefore, Uwe Hohn record of 104.8 meter cannot be achieved by any athlete. Okay, therefore that record is now set as eternal record. Okay, so these are the main cause of uh, the redesigned javelin, and the cause why this 104.8 meter record made by Uwe Hohn is called as eternal record. Now, science behind the flight of original Javelin. This is the Javelin, this is the center of gravity, and in this direction the drag of the air or wind will act, and in this direction the velocity of the Javelin will act, and again in this direction the lift of the Javelin. That after projection of the Javelin, these three forces will act upon the body, okay, body of the Javelin. One is dragged by the air or by the air, and another is the velocity of the Javelin in the forward direction, and the lifting of the Javelin to the upward direction. And this angle, the red line joining the center of gravity with the velocity angle, velocity vector, this angle is known as angle of release. That means velocity always act on the center of gravity. That means when the Javelin is thrown, the center of gravity is moving, okay, along with the Javelin. So this center angle between the velocity and the line joining the center of gravity with the surface of the Javelin is known as angle of release, and this is the line joining tip to tip, okay. That means this is the orientation of the Javelin, okay, around the center of gravity. So this is the longitudinal axis of the Javelin, okay. So this longitudinal axis will make an angle with velocity vector, which is known as angle of attitude. Now this is the original, we are discussing about the science behind the flight of original Javelin, that is the Javelin used by Uwe Hohn. Here the center of gravity and center of pressure is at the same point. Now the difference between the angle of attitude and angle of release is known as angle of attack. So for an ideal throw, this angle of attack must be minimum. During the Uwe Hohn throwing of the Javelin, as the center of gravity and center of pressure was at the same point of the Javelin, therefore the angle of attack was minimum, and at this condition the Javelin will fly up to a higher order distance, and it will fly like a flat stick, and after the flight it will have a flat landing on the ground, okay. So with this type of Javelin and with this type of condition, the Javelin will follow this type of path like this, and finally it will landed on the ground like a flat stick. Now what is the science behind the flight of redesigned Javelin? Okay, so this is the redesigned Javelin, this is center of pressure, and this is center of gravity. As we already discussed, in the redesigned Javelin, the center of gravity is shifted by 4 centimeter from the center of pressure. So here this is the lift forces, force, this is the dragging force, and this is the velocity of the javelin acting in the forward direction, dragging force acting in the backward direction, and lifting force acting on the upward direction. This is the axis, longitudinal axis of the javelin, and the angle between this longitudinal axis of the javelin and the velocity vector of the javelin is known as angle of attitude. And this is the axis connecting center of gravity across the surface of the javelin, and it will make an angle with velocity vector known as angle of release. And in this redesigned javelin, as the center of gravity is shifted forward by 4 centimeter, that means these 2 points are not situated at the same point, therefore the angle difference between the angle of attitude and angle of release, which is known as angle of attack, is not the minimum. There is a difference between these two angles, and with this type of condition, for the javelin will follow a path where the javelin started to descend earlier compared to the original one, and the javelin stick into the ground, avoiding the flat landing. Okay, because the the original javelin was landed like a flat stick on the ground, but because of this the changes made on the javelin, it will descend earlier and stick into the ground, avoiding the flat landing. And the motion of the flight of this javelin is known as projectile motion. Okay, so for an ideal case, in case of a projectile motion, for ideal, the projectile will cover the maximum horizontal distance when the projection angle, that is angle, that means the angle of release, will 45 degree. That means when the projection angle is 45 degree, then the projectile will cover the maximum horizontal range. But in case of javelin, and again another point, when the projectile is projected in the upward direction, then if the projectile is projected from the ground, then this is the ideal condition where at 45 degree angle the projectile will cover the maximum horizontal range. But in case of javelin, the javelin is thrown to upward direction at a level up to approximately 2 meter above the ground. That means the athlete will throw the javelin, and that point, when the javelin is ready to throw, at that point the javelin will at about 2 meter above the ground. For this condition, and again for the aerodynamic forces acted upon the javelin, the optimum angle for the maximum horizontal, to have the maximum horizontal range, the optimum projection angle must be between 32 degree to 36 degree. Okay, so between this 32 to 36 degree, if if the javelin is thrown, then it can cover the maximum horizontal range. Okay, now this is the you can see the flight of the javelin thrown by Niraj Chopra with the redesigned javelin. Okay, with this redesigned javelin, when Niraj Chopra threw his javelin during his Tokyo 2020 Olympic, this is like this, and finally the javelin started to descend earlier compared to the original javelin, and the javelin stick into the ground, avoiding the flat landing, like the javelin thrown by Uwe Hohn in 1984. So this is the expected path of the flight thrown by Niraj Chopra. Okay, and again, as this throw is an example of projectile motion, we can calculate some expected values using the mathematics connected to the projectile motion, where we can find out the range, then maximum height the projectile or the javelin can achieve during its flight. Okay, so we know Niraj Chopra covered about 87.58 meter during his historic javelin throw, because of which he got the gold medal for India. That was R is equal to 87.58 meter, and if we consider his projection angle is 32 degree, then we can calculate using R is equal to 87.58 meter and angle of projection theta is equal to 32 degree. We can calculate the velocity with which Niraj Chopra threw his javelin. That will be 30.9 meter per second or 111.24 kilometer per hour. And again, we have already discussed that for maximum horizontal range to cover, the projection angle must be lie between 32 degree to 36 degree. Okay, if we take the Niraj Chopra's projection angle was 36 degree, then his initial velocity will be the initial velocity of the javelin was 30.11 meter per second or 108 kilometer per hour. Okay, that means between, if his angle of projection lies between 32 to 36 degree, then the initial velocity of the javelin also lies between 30.9 meter per second to 30.11 meter per second. Okay, and with this data, we can find out the maximum height that will achieved by the javelin thrown by Niraj Chopra during its flight will be 30 meter, and time of flight, that means how much time the javelin was on the sky, it will be t equal to 1.67 second. Okay, so these are the some expected values that can be calculated using physical formulas or mathematical formulas for the flight of javelin thrown by Niraj Chopra during his Tokyo 2020 Olympic, and for which he makes all the Indians to feel proud. Okay, so these are the uh, mathematical expression or mathematics or science behind the javelin thrown by Niraj Chopra. Again, in case of Uwe Hohn javelin throw, this was the expected path followed by the javelin thrown by Uwe Hohn in 1984 for his eternal record, and Uwe Hohn's angle of attack was expected as 31 degree, and the projectile velocity was expected as 32.5 meter per second. Okay, so these are the science and mathematics behind the flight of the javelin thrown by Uwe Hohn for his eternal record of 104.8 meter, and the gold medal achieved by Niraj Chopra for his historic uh, throw of javelin during 2020 Tokyo Olympic. Okay, so thanks for watching.